Magneto comprises key components: a top menu bar, a message area, a command line, a bottom status bar, and a model tree with a search feature on the left. To conduct a simulation with Magneto, you'll need a geometric model of the system, obtainable through the built-in geometric modeler or by importing geometry created in commercial CAD software. We are going to model a permanent magnetic generator for a demonstration of Magneto's setup and analysis features. Begin by importing the geometry viewable in the message area. Configure units either from the model tree or the utilities menu. Geometry objects are set U for easy labeling and selection. This dialog can be opened using the toolbar or the model tree. Create 4 generic objects by left-clicking the Create button 4 times. These objects have random colors, no assigned geometry, and are sequentially named Object, Object 2, and so on. Right-click each object's name and rename them as rotor, stator, forward coil, and return coil. To assign object regions, use the Add Region button. Magneto initially treats models as infinitely long structures. For simulating axisymmetric models, modify the 2D setting to axisymmetric X or axisymmetric Y, based on the model's orientation. For 2D models, Magneto computes force and torque for a 1 meter length in the third dimension by default. Adjust the third dimension length to 40 millimeters in Magneto for accurate calculations. Next, assign materials. Open the material table from the physics menu. Assign material to the rotor as part of the magnet definition and apply 1010 steel to the stator. Leave the forward coil and return coil without material assignments. Magneto assumes a background material with a permeability of 1 for regions lacking material. The rotor region becomes a permanent magnet. From the physics menu, select the Add Permanent Magnet dialog box, specifying neodymium-10 as the material and magnetization direction XU I1. Click the plus button to assign magnetization to the rotor region, which will turn orange with upward-pointing arrows. The model is now ready for solving, but first, define outputs via the Solution menu. Under Define Outputs, navigate to the Plots tab and create 2D contour plots with the specified properties. Define an arrows plot, choosing Location as a plot object. Rename plots as needed. In the Measurements tab, add field probes for magnetic field values at selected points. Close the Defined Output dialog. Proceed to the Solution menu, select Run Solver, and monitor progress in the Output Manager. To view the plots, click Show Step. Modify the arrow presentation by right-clicking and selecting Properties. Apply the changes and close the dialog. From the Analysis menu, select Flux Linkage. Follow the command line prompts to choose the forward coil, then the return coil. The flux linkage value appears in the message area. This session introduced fundamental techniques for performing magneto simulations.